Hey everybody, here's a short asynchronous video on scatterplots and correlation. Um, we'll get started. So um, a scatterplot is used to investigate the relationship between two variables. And when I say variable, I really mean in like the real world. And we're going to talk about specifically variables that are measured with that have number answers. So here's two variables. Temperature is one, and this is actually ice cream sales here on the y-axis. So in this relationship, there is a dependent variable, ice cream sales, and that's actually relying upon the independent variable, temperature. So as the temperature goes up, so does the sales of ice cream, and I can see that from the graph here. When we have a scatter plot, it's often useful to have a line of best fit. A line of best fit is a straight line that represents, in general, data on a scatter plot, like shown here. So notice here, I have some dots, and then I put a line through it. The line doesn't need to touch any of the actual data points. In this case over here, it does touch two of them, and it doesn't need to go through the origin. The line of best fit is a model of numerical two-variable data that helps describe the relationship of the data so that we can make predictions for other values. Describing an association, there are three things we're going to describe. We're going to describe direction, form, and then strength. Direction, it's either positive or negative. Form, it's either linear or nonlinear. Strength is either strong, moderate, or weak. So direction, if I look here, I've got number of white hairs on the scalp. And then this is mineral density. So here I can see it's kind of going down. So this has a negative association. Here, there's time on exam and then grades. And I can see even though they're kind of spread out, still overall, they're kind of going up together. So we'll say this is positive. Here, I've got two variables, and I can see, so this is like length and success. And I can see here that it's overall going down, so there's negative. So it's decreasing. Form, I can have linear, so the best thing I could draw through here is a line. Can also have nonlinear. See how this data is kind of curving? If I was to try to model it, it would be best if I could have something that was curvy. So this is, we would say this is nonlinear. And here, there's kind of like two gaps, but even if I had to make a model, I would still make a line. So I'd say this is linear with two clusters. Strength measures how closely points follow a pattern. So here, this is one from the previous screen. Here I can see they're kind of spread out. I would call this weak. Here, they're a little closer together, but there's still a fair amount of scatter. They're kind of spread out. I would call this moderate. And then this one going down here, this one, even though it's curvy, this is very strong, because if I was to put a nice curve in there, those dots would be pretty much in a line in that pattern. For outliers, an outlier is a data point that does not fit the overall pattern of the data. So like here, if I have this curve and then an outlier over here that's not following the pattern. All right, so this is just a quick intro. We're going to start looking at these occasionally in homeworks, and then in a later chapter, we're going to really talk about this topic more in depth. All right, everybody, have a good day.